We've briefly looked at M31 during the Arp Evidence series and speculated that its blue shift is not due to its motion towards us, but instead that it is intrinsic. In a new study, astronomers have attempted to map the gases surrounding M31 and come to the startling conclusion that its halo is already touching our Milky Ways. Let's find out what else this study can reveal. Most of the matter in our universe is very hard to see, but techniques are improving to try and make this invisible matter visible. We suspect that all galaxies have halos that surround them. Seeing this halo is a very complex task. Most galaxies are flattened disks, but the halos that surround them appear to be spherical and extend for vast distances beyond the visible galaxy, up to many millions of light years. So how do you study something that is barely visible and gives off little radiation itself? Instead of looking for the material itself, they look for the effects that this material might have on light that happen to pass through these clouds of material. By examining the light of quasars and seeing how various parts of the spectra are absorbed by this gas, they are able to try and piece together a picture of what the material is and how far it might extend. Andromeda, or M31, is our closest galaxy, and they are able to identify 43 quasars scattered around it that they could use. They examine the ultraviolet light of these quasars and how it was absorbed by the material in the halo. Now, they obviously believe that these quasars make good sources as they consider them to be distant and bright. But there is a totally different way of looking at this. More on that in a bit. When they analysed the results, they determined that the halo had a layered structure with one shell of gas nested inside another. They also detected large amounts of heavy elements in these shells and attempted to link this with supernova explosions. They were also able to determine that the outer layers reach much further than they had previously thought. It extends 1.3 million light-years from Andromeda, and in some directions as far as 2 million light-years, and this means that Andromeda's halo is already intersecting with the Milky Ways. So let's break this down in a slightly different way. So first up, they used quasars that surround M31, and when we examine the location of these quasars, we once more see a clear clumping. There is a clear line stretching from M31 towards M33, and also a predominance of quasars below M31, with very few above it. When we then overlay the position of all the dwarf galaxies that surround M31, I see a strong line of them out to the north and a line running along its minor axis. We also see the redshift velocity plotted on this graph. Looking at the dwarfs, we see a higher redshift in the northern line closest to M31, and this decreasing and becoming blue as it moves further out. To the south, it is not present, and may be due to the fact that this line is angled towards us, meaning this additional component may cause this shift. If we turn our attention to the quasars, we see that many of them have multiple colours, and this indicates multiple different components which they detect. Some moving towards and some seemingly moving away from us through the same slice. This they use to identify different shells that they think are moving at different speeds and are composed of different material. So does this data not prove that the quasars must sit much further back behind this halo? Well, no. When we looked at NGC 3067 and 3C232, we discussed that the mainstream argument for the quasar not being part of the hydrogen filament was because of the ultraviolet emissions, which showed that the quasar must be more distant. The photons that they need to ionize the hydrogen in the filament and make it fluoresce were at a shorter wavelength than those in the spectrum. So they needed to extrapolate to an unobserved portion of the spectrum. The amount of shift required would depend on the amount of hydrogen at the redshift intermediate between the quasar and the hydrogen filament, the degree to which the filament was composed of small dense clouds, and the relative beaming angle between the ultraviolet and the radio wavelengths of the quasar. So is exactly the same occurring here? If some of these quasars are actually ejected out of M31, all the associated galaxies along the line from M33, then they would be much closer and yet have a higher intrinsic redshift. Now the question is whether this material as then being detected is connected or surrounding the quasar, so along the lines that we previously discussed. There would be filaments of material in which the quasar is formed, or is M31 ejecting shells of material like we discussed with Jim, which itself would have different redshifts. This would mean that the quasar light may well be passing through a series of shells before reaching us. Equally, if we are considering that there are instead filaments connecting these objects together, then the light may also be passing through a series of filaments between it and us. As always, be brave, be curious, the truth is waiting for us. Until next time.